Okay, Assalamualaikum and salam. Okay, today I want to do a practical walkthrough report. Okay, I will explain you how I get result for this practical work. First of all, my name is Awang Kamil Rashad bin Awang Zaman. My number metric is 20DE19F 2017. Code khusus is the P40053 fiber optic communication system. I'm from class DE4A, and my lecturer is Encik Nauran Hairul Arifin bin Abdullah. Okay. Okay. For the title of this practical work, two is properties of light, wave, and light behavior. Okay. Okay. For the experiment one, observe the experiment, then answer the question below. Okay. If you want to see this fully practical walkthrough, okay. Okay. This objectives for this practical walkthrough is to understand the light propagation, and B is to investigate properties of light wave and light behavior, diffraction and interference. Okay, for the equipment is on a online simulation. Okay. Okay, we proceed to the experiment one. Okay, sorry. um okay, for this experiment one, this is our online simulation, and the question we want to do is define the constructive interference, and based on experiment, then label the constructive interference at any point 11 on this experiment. And the question 2 is define the destructive interference, and based on experiment, then label the destructive interference at any point 11 on this experiment. Okay, in this experiment one, uh, we must to find the define for the constructive interference and destructive interference, and label the constructive interference and destructive interference on the online simulation, and paste it on the report. Okay. So the answer for define constructive interference is when two waves of identical wavelength are in phase, they form a new wave with an amplitude equal to the sum of their individual amplitude. Okay, that is for defined for the constructive interference. Okay, for the destructive interference is destructive interference occur when the maxima of two waves are 180 degrees out of phase. A positive displacement of one wave is cancelled exactly by a negative displacement of the other wave. Okay, that is defined. Okay, how I get this label? So we go to the online simulation. Okay, this is our online simulation. We choose the interference. Okay, and we pick this one. Okay, and like, then on the graph, and we put slope, so we can see the result. Okay, first we open this in 1 second, and we open this, and we will waiting the okay. Oh, sorry. Okay. In this result, this is our constructive. The white uh, component is this white is constructive. This is destructive. Okay, for the constructive, we put at here. So the waveform will be like this. Okay, and this is destructive. We put here, and it will be like this. So this is label. We can label it. This is for constructive, and this is for the destructive. Okay, so that's all for the experiment one. Okay, okay, we proceed to the experiment two. Experiment two. Okay, observe the experiment, then answer the question below. Okay, what happened to the strength of the wave if slit move near to the source? And what happened to the strength of the wave if slit move far from the source? Okay, for this experiment too, we going to use this one. Okay, we go back first again. We choose the slit. Okay, so click and on the graph and pick the we not using water wave, we using light generator. Okay, and we pick the component again, and don't forget we just run it slow. Okay, on first. Okay, as you can see, this is experiment two, but the question once is what happened to the strength of the wave if slit move near the source, and this is far from source. Okay, so my answer is when wave slit move near to the source, the wave will faster bending. So I will show you here. You see, the bending will be faster. Okay, so when we go far, the bending is low. Okay, so that is for the experiment two. Okay, so that is my answer. Okay, we proceed to the experiment three. Also same, observe the experiment, then answer the question below. Okay, for the first question is what happened to the light of the wave if increase the diameter of this object? Okay, so my answer is the light will be blurring and the object will be small. Okay, I will show you for the experiment three. So going to use time simulation, but we're going to use diffraction. Okay, this is for the experiment three. So we on the light. Okay, The question is, what happened to the light of the wave if increase the diameter of this object? Okay, when we increase the diameter, you can see the uh, the object will be the light of object will be blurring and small, and we can see the small circle here. Okay, so that is the answer. And for the question 2 is using the object tree, what happened to the light of the wave if increase the diameter of the circle only, then the square only? Okay, in here we can also we can use it, we must using the object tree. This is object 1, object 2, and object 3. Okay, okay, the question is, he want to know what happened the light or the light of wave when we increase the diameter for the circle only and the square only. Okay, we do the circle first. Okay, we increase the diameter, so you can see the circle will be blur, but the circle is big. The light of circle is big, and the square will be blurring and cannot see the square. Okay, when we goes to increase the square diameter, okay, as you can see, when we increase the square diameter, okay, you see the square is small, and the circle will blurring behind this the square. Okay, so that is for the practical experiment 3. Okay, so we proceed to the next question is using the object tree also, and what happened to the light of the wave if increase the diameter of the circle and square. So that means the question 1, we to increase the diameter for the circle and square same. So the result is like this. But you can see the wave of the circle and the square wave in the middle. Okay, so this is happen when the diameter for the circle and square increase together. Okay, so that is for the experiment 3. Okay, okay, we proceed to the experiment 4. Fill the table below. Okay, for this experiment 4, we go to this. Okay, click link simulation from CDOS and practical work tool, and we using the numerical aperture simulation. Okay, refer to the figure 11 and set up this parameter for of this experiment using click the object below. Okay, they have 4 object. Okay, emitter, fiber stand, fiber cable, output screen. Okay, you can see this is output screen, fiber stand, fiber cable, and emitter. Okay, so the question is fill the table below. So here the question already give the distance of screen in mm 0 until 20. So we must find the diameter for the fiber cable. Okay, we goes to the simulation for experiment 4. Okay, this one, click the link. Okay, we click first emitter, fiber stand, fiber cable, output screen, and we start the okay. You can see here, this is our output screen. Okay, screen, and we must using the fiber cable. Here have two cable, glass fiber and fiber cable. So we choose fiber cable first. Okay, this is our diameter. Okay, we put it from 0. Okay, okay. So we see the project. We see the experiment 4 table. Okay, from 0 until 20. So I will choose 14. 14, and my result is 15.554 mm. So we choose 14. Okay, 14. 1, 2, 3, 4. Okay, so the diameter for the 14 mm fiber cable is 15.554 mm. So my answer is correct. Okay, so we get the answer and paste it on this table. So that is how I get the result for this experiment. Okay. Okay, for the question 2 is we plot the graph. Okay, plot the graph. Distance of screen L in mm vs diameter D using the Excel. Okay, if you can see, this is our graph. Okay, diameter in the left side, and the distance of screen is in the bottom. Okay, this is how the graph will plot from using the Excel. Okay, this is my result graph when I do it in Excel. Okay, so the title is the graph distance of screen in mm vs diameter in mm. Okay, using the fiber cable. Okay, so for the next question is find out the gradient. Okay, in Excel we can get the gradient. Okay, so the gradient is for this fiber cable is y equals to 1.111x minus 0.0005. Okay, that is the result or answer for the gradient fiber cable. Okay. Okay, the question 3 is write the equation of the relationship between numerical aperture distance of screen L in mm and diameter D. And he already give hint and A equals to gradient. Okay, so for the my answer is the equation of the relationship between numerical aperture distance of screen and diameter is our wavelength, because when we can see the result here, he already give the wavelength. Okay, and the SI unit also same, and the gradient and to get the gradient also same. Okay, so we proceed to the next table is using the glass cable. Okay, also same, how we get the result, like the table 1 fiber cable. Okay, so I give the example for the number 10. So just here we just move to 0, and here we change to glass cable. So we put at 10 mm. Sorry. Okay. For the answer is answer for the 10 mm diameter is 19.028 mm. So we check our answer. Correct. Okay, 19.028 mm. So that's how we can get the diameter result from the simulation. Okay, and the next question is our to plot the graph. Okay, this is a graph for glass cable, and he already give the gradient. So the gradient is y equals to 1.9029x minus 0.001. Okay, as you can see here, the difference uh, uh the difference gradient in two object two cable is the C is 0.005. Okay, and for the glass cable is 0.001. So that is the difference. Okay, so the next question, the last question is also same like table 1. The result is wavelength. Okay, so that's all from me. Thank you.